Welcome back to Cloud 42. I'm James. This is going to be part 3 of the Toolpost grinder video series. In part 2, we made the spindle body and we bored it out for clearance and bored out seats for the bearings and a diameter to thread for the bearing lock rings. Today we're going to start on the bearing lock rings and get those going. Let's go over to the bench and take a look at the plans. These are the bearing caps that we're going to make today. You can see these have to be bored through for clearance, and then there's a bearing register that has to be bored in one side, and then the outside's turned to diameter and threaded, 28 threads per inch. And then the whole thing has to be cut off. The width is 236 thousandths. I'm reading the plans upside down here. I have a chunk of 12L14 steel. This is what's left over from making the spindle body. I think we'll use this. There should be enough here to get both of these out of the one piece. I think I want to start with boring it out, drilling and boring it out. Since we had a little bit of trouble with that last time, I want to do that first so that if we have problems again, I don't end up scrapping the part and wasting all the effort on the threading. Let's go over to the lathe and get started. Now I'm going to try to leave enough stock hanging out here that I've got enough to make 3 bearing caps. Why 3? Insurance. I only need 2, and if I leave enough stock out for 3, then if I have a problem, I can make another one, and if I don't have a problem, then I don't have a problem. Okay, I already preset these jaws to about the right position, and that is not even close. Get this roughly a little more centered. Okay, let me get a dial indicator and let's dial that in. That's the high, that's the low. Loosen the low here. Tighten the high a little bit. Loosen the low. Tighten the high. That's now the high. Chase it around here a little bit. Well, that's looking better. That's the high. There we go. We got it running within thou and a half. That is going to be good enough. What about out here on the end? 1.5. I can live with that. 2.5. Either way. Okay, I'm going to start by facing this off, so I have a clean surface to drill into. Doesn't look great, but it feels pretty good. Okay, since we're going to be drilling now, I'm going to drop the speed quite a bit. In fact, I think I'm going to go to the back belt here. Start around 300 RPM. Probably drop down when we get to the biggest bits. Okay. Let's start with a 1/4-inch spotting drill. Good for that. Now let's find a 1/4-inch drill to push through here. And this is the closest one I got handy. This is an M, so 290 should be fine. Little oil. And we're through with that one. Okay, let's find a 1/2 inch. Okay, this is not a 1/2 inch, but it's close. And for this drill, I think I'm going to drop the speed down to 150. You know what? I'm going to go ahead and run it like this. We should be okay. We're at 300 right now. Got to the end of my ram on the tailstock. Got lots of smoke, a little bit of complaining, but it's going through. Some of that's the 12L14, the way the chips break. Make that lovely noise. And should be one more and we should be there. And we're through. A lot more noise, but a lot less drama than last time. And way faster. Yeah, that's much better. Much better than the last trip through a piece of metal like this. Okay, now before I turn this up on high, I'm going to wipe some of this oil off of it. Since I have no need or desire to be covered in cutting oil. Okay. Okay, this will be 2400 RPM. Before I start boring here, let's adjust this. Looks like I want about 2 inches of stick out so I can go all the way through. That should be enough. Okay, we're going to start by taking 20 thousandths. Yeah, let's get rid of those big chips because when the jaw hits them, it throws them. And they're hard and they're hot and they're heavy. Okay, so we're headed for 965. Let's get a quick measure and just see where we are. 925. Let's take 10, which should take us to 945-ish, and then we'll start measuring with a micrometer. Okay, and again, we're headed for 965. Right there so I won't forget. We're at about 949. And we're going to 965. Meaning we need to dial in 8 thousandths to take 16 off of the diameter. So let me dial in 8. And that should put us right on target. Probably slightly over because the tool pressure will be slightly less. $967. Yep. That will be close enough for the bore. Okay, I think now we just need to turn the outside to diameter. I think this is going to be just a touch fast for that. It's going to put us over our target 800 surface feet per minute. Okay, it's been at 1200 RPM, which will be a little under, but you know, that's what I have to work with. So that's what we use. Let's just see where we are. Looks like we are 1.581, which means we got to take 105 thousandths off the radius. So I think I'm going to take 80 in 20,000 steps. Actually, let's try 30 and see what happens. Actually, that's much better. 30 thousandths doesn't throw chips as far. This will make 90 and then we'll measure. .404. There we go, 1.371 exactly. Okay, next step is to set the lathe up for threading. These are the change gears on the G0602 lathe, and it's a pain to change them because of the way the banjo is set up. I took a few minutes and got these changed out, and the difficulty of doing this is just the inconvenience is the reason why I wait as long as possible. So according to the thread chart on the front of the lathe, if I want 28 threads per inch, then I have to have a 36 tooth gear and a 56 tooth gear. So normally when this is set up for feeding with the lead screw, there are 3 gear reductions. But when it's set up for threading, there are only 2, and this large 127 tooth gear is only used as an idler. If you're going to use metric threads, then it's a 127 and there's a 120 tooth gear, so that reduction is there to convert from an SAE lead screw to metric threads. But since this is an SAE thread, 28 threads per inch, this is just used as an idler. And so this is the 36 tooth gear and this is the 56 tooth gear, so that's just a direct ratio because this is set up as an idler. And I've got these set up so I've got just a little bit of backlash in the gears so that they'll run quietly and won't wear. And we should be set up and ready to thread. Okay, I've got the lathe gears set up for threading. I've got a carbide threading tool squared up and in the tool post holder. And I've got the compound set to 29.5 degrees. And there's nothing magic about 29.5 degrees. It's just that the thread tool is a form cutter with a 30-degree angle on the side, and so we set the compound to 29.5 so that it won't lose contact. It'll just glide right down that side, shaving it and creating a perfect 30-degree bevel or 60-degree included angle on the point. Okay, so the first thing to do here is I want to cut a groove back here as a runout area so that I don't have to quick draw. And we'll just cut some space so that we'll have clearance for the tool to run into at the end of the thread. Okay, that should be the biggest of plenty. That's actually way more than I'm going to need, but it'll give me a safe place to run off into. Now let me zero the tool up on the work. I've already got the compound set to 0, and now I'm going to touch off and set the cross slide to 0. That's 0. Let's set the dial to 0. Okay, and I'm going to set this for maybe 1,000th, and I'm just going to take a scratch pass across the piece to verify that I am cutting 28 threads per inch. This is nice and slow. This will be really easy. Pull out, back across, back into 0 on the cross slide. And let's get a thread gauge and check and make sure that's really 28 threads per inch. No, that's not right. That is not 28 threads per inch. Okay, let's look at this again. It says for 28 threads per inch. Ah, here it is. I have to be set to 1 and A. Okay, we'll use a little oil. And we'll take 5/1000ths on the compound for the first pass. Take another 5. Waiting for the threading dial to come around to my number. There we go, now we're starting to cut. Doing it's starting to cut now. Take another 5. Now let's take a quick break here and let's just see where we are on depth. Clean these out as best I can. Okay, I did the calculations for the thread wires and it's on the drawing. And it says I need to go 1,390 over 240 wires, or 24 thousandths wires. And I have 24 thousandths wires right here. And let's see where we are. Got a feel for the high spot here. And it looks like we are at 1,397. So we need to take 7 thou more. So I gotta take half of that. I'm gonna take 3 off of each side. And let's see where that gets us. Waiting for my number to come around on the threading dial. Okay, looks good. Now that the threads are nice and deep, I'm going to check the pitch again, because there's no reason to finish these if I cut it to the wrong pitch. Yeah, that looks good. Okay, let's check the diameter over the wires. Two on the bottom, and then use the micrometer to hold them. And then slide one in on the top. Okay, that feels about the largest diameter there. Let's see what we've got. I think perhaps my last measurement wasn't good, because we've got 1398. So 8 thousandths to go. Let's take a couple of 2 thou passes. There's 2. Wait for my number to come around. And take 2 more. Again, waiting for my number to come around. Clean these out, and let's see what we got. Can easily get a thou or 2 difference just by picking the wrong thread here, so. Okay, that looks good. And that is 1390 and 3/10. I'm going to call that good. Let me clean these up a little bit. See if that takes the sharp edges off at the top. Oh yeah, and that did a beautiful job. Some ultra fine Scotch-Brite. And something to clean out the threads here. Let's use a brush. Don't want to grab it while it's turning because I'm sure it's still sharp. Okay, that looks pretty good. At least as good as I'm going to get for this material. Well, you can tell that it's 10 a.m. on a Saturday when I'm filming this because my neighbors are mowing the lawn. It is 10 a.m. every Saturday, just like clockwork. Well, I've got a slug here. This is enough material to make 3 bearing caps, and it's already threaded. I only need 2, but I am smart enough to go ahead and thread enough for 3 because I know my limitations. So what I have to do here is I have to bore out a pocket for the bearing, 79 thousandths deep, 1.260 inches in diameter to accept the bearing, and then once that's bored to size and depth, then part it off and then do it again and maybe do it again. And so to get to 79 thousandths, I've got a dial indicator down here. On the carriage, I don't have auto feed because I still have this thing set up for threading. So let me bump very lightly here so I don't chip anything and 0 the indicator. Let me get clear. Come back to my 0. Now I need to go 79 thousandths deep. So that's 79 thousandths right there, and I will re-zero my indicator. So this is my stop point when I'm boring for depth. Right there, that's how deep the bearing pocket needs to go. When I make my initial passes, I'll try to stop about 5 thousandths shy of that. Now to measure the diameter, 79 thousandths is probably not going to be enough to get a bore gauge in there. So I'm just going to do it with calipers. And to make this job easier so that I don't have to do basic math, which I've proven, if you've been watching closely in the videos, I can't do. I went ahead and zeroed these calipers at 1.260, which is my final dimension. So now when I measure the bore, for example, it's showing me I've got about 300 thousandths to go. And we'll go with this and start checking the bearing fit when we get very close. Now I've got the lathe slowed way down. I'm running it at 720. Hopefully I can avoid some of the chatter and squeal that I was getting at the bottom of the bearing pockets on the other pieces. But honestly, I'm not real happy with this 12L14 in the way it turns on this lathe, but live and learn. Now I'm just going to check and make sure that makes sense, being 79 thousandths. Just to make sure I didn't screw anything up. Yep, that looks right. Okay, that was 3 30-thou cuts, so it should have taken 180 off, leaving me about 120 to go. Let's see if I can do that basic arithmetic right. Yeah, it says 118. 118, so let's take another 30, which will actually be 60. See where we are. Yeah, so it says we need to take about 55. So let me take 25, which will give me 50. Let's see. Knowing what I know about the surface finish on this, let's see if we can go straight to size. So instead of 25, if I've got 50, let's see, depending where I measure here, 56 to go. Let me grab a bearing and measure with my zeroed calipers and just make sure I'm in the right ballpark here. Yeah, 0, that's right. So, again, caliper dimensions are not terribly accurate, but there's no way I can get a bore gauge in here, telescoping gauge. So 57, 58. Let's say we want to take 58 off of this. Then half of that would be 29. So let's just do it and go right to the number. See what we get. I'm going to deburr the edge before I test. See if the bearing fits. Oh my goodness, the bearing fits. What do you know? Okay. So now I'm going to go to the bottom and back bore the back face. That looks pretty good. Now let's see how close we actually got. Okay, looks like we are 2 to 3 thou, 2 thou oversize, and that should be fine. Because again, this thing is just to clamp the bearing in place. And that feels good. Okay. Next step is to part this off. And grab a parting tool. And how thick does it need to be? It needs to be parted off exactly 236 thou. So what I'm going to do is I'm actually going to use the calipers for this. Set these to 236. But I actually want to part this off maybe 10 thousandths, maybe 15 thousandths long. Let's go for 15. So instead of 236, go to 251. And the reason is so that I can face it off on the other side. Okay. Hit this as close as I can. Okay, that looks pretty good. And lock the carriage until I haven't used this carriage lock in a while. see how we do. We may need to slow it down. Yep, we're going to slow it down. Now before I actually part through this, I want to chamfer the edges, but I want to get back exactly to this position, so I'm going to set up reset my dial indicator to 0 here. I'm just going to put some light chamfers here to clean up the edges of the thread. Do both sides there while I'm here. And then we'll go back to our cutoff tool, parting tool. Back to our 0. And I will lock the carriage again, just to avoid any unpleasant surprises. Now let me get something to catch the part. Drill chuck in the tailstock, and okay, part's ready to catch. Let's finish parting it off. And there we are. Wow, that parted finish is beautiful. There's one thing that's good now that I found about this 12L14 is it does part beautifully. Take the sharp corner off of that. And off this. Which of course I could have done in the lathe. Looks good. Okay, now I just need to do that one more time, or if I screw up, 2 more times. Okay, now I need to set this up on the mill so that I can drill or cut the 2 pin spanner holes in this. I'm going to use an 1/8 inch end mill. It's a 4 flute, but it is center cutting, so it should be no problem to plunge that in and cut the pin spanner holes. So I've got some aluminum soft jaws with a V-block in the vise to hold it, and I don't really want to clamp down very hard because the threads on this will cut into the vise jaws, and I also don't want to push it out around, but it's not going to take much, so I should be able to just grab it lightly, and it should be plenty for this operation. especially since all the force is going to be down here, and it's between the parallels, almost in line with the bearing points there, so it should be fine. If it's not, we'll find that out too. See how close we are side to side. Not at all. Take this out of gear to make it easier to spin. Honestly, that's not too far off. So let's take it in. What happens here? See where we are. Okay, we're going to need a little bit more. Okay, 15 at the bottom. At the bottom. Bring this around and get that closer to 0. So that's about 0 there. It's about 0 there. It's about 0 there. Okay, so let's get finer. So front to back, about a half a thou under 0. And here I'm about a half a thou over 0. So that puts me right about 0 there. Right about 0 there within a half a thou. That's right on 0. And that's about a half a thou under. That is going to be close enough for what we're trying to do here. So let me zero my DROs over here. Take the dial indicator off. So now that is the exact center of the part. So now in order to put the holes in, the space between the holes is supposed to be 181. So let me move over 590. Okay, this is a 10 thou brass shim. I'm just going to place it there. Get my light here, and I'm going to bring this down and touch and 0 the quill readout. I'm going to go 118 thou deep. Okay. And that will work much better if it's in gear. I'm going to go ahead and put a little oil in there. That is 118 thou. Looks great. So let's go 590 on the other side. And there's 590 on the other side. A little bit of oil. And we'll do the same 100 and... Actually, you know what? This is thicker than spec. This was 250 instead of 236. So I need to add that on. So I'd add another 14 thousandths to the 118, so we need to go 132 deep. And I'll go back over and fix up the other one. That's 132. We'll go back to the position we were at before. Okay, and we'll take this one back down to 132 also. There we go, 132. Now we've got 2 more to do, because I'm going to go ahead and finish all 3 of these. Take that out. Yeah, that looks good. Well, I'm very happy with how these bearing caps turned out. Pin spanner holes are nice and clean. The threads turned out great. The bearing pockets fit very, very well. They're very tight. The bearing stays in. Well, this one's going to fall out. They're very, very close. There's essentially no play. I can't feel anything there. And they stay in. So I think these are going to be great. The next step, of course, is going to be to thread the inside of the spindle body to accept these, and we will do that next time. As always, comment below and give me a thumbs up if you enjoyed this video. If you didn't enjoy this video, then I guess I'm not really sure why you're still here. Maybe you're just letting it roll while you're typing a comment in all caps. For the rest of you, be sure to subscribe so you'll get notified when the next video comes out, and thank you for watching.